GM OE fitment conversion to aftermarket standard. Let's begin with showing you the end goal of what we're trying to build. We're going to use ARAPA data, which is not understood outside of GM. Next, we convert it into ACES format, which is well understood in the industry. We are able to send out an XML format to any catalog receiver. To the left is an example of our 2015 GMC Sierra 1500 truck ACES record in an XML format, which will be used to provide data for our online catalog. This whole process starts with AutoCare. The AutoCare Association plays an important role in vehicle and part mapping. It provides the industry standard in North America with vehicle fitment information. Components of the AutoCare Association include PIEs and ACES. PIEs is anything used to describe the part. The PIEs standardized format includes attributes such as description, price, dimensions, and weights, among other things. The ACES standard provides proper fitment data, what part fits what vehicle. AutoCare has a huge impact in the aftermarket industry. It supports $368 billion in the AutoCare industry and has 500,000 users of the data. For a 2015 GMC Sierra, a person could name the vehicle multiple ways. In order to avoid naming it 3 different ways as shown here, the VCDB provides a consistent name and number to identify the vehicle. With the AutoCare standard, this particular vehicle is assigned a base vehicle ID of 129846, as opposed to being called many different names. Here's an example of why we need a standard for a part description. Each part type is assigned a part type ID. For example, with the AutoCare standard, the windshield wiper blade is assigned a part type ID of 8852. The process for obtaining part data for AC Delco aftermarket parts is different than the process for obtaining part data for OE parts. For AC Delco aftermarket parts, the supplier is responsible for sending the part data to GM in ACES and PIEs format. For OE parts, we have to use ARAPA data, which only GM resources understand, and convert the OE data to ACES. It's important to note, the whole focus that we are talking about today is on GM OE part process. So again, in order to display OE data in a catalog, we need to convert ARAPA GM data to ACES. This visual demonstrates how ARAPA data cannot be used to populate an online catalog, but by converting it to ACES, it allows us to put it on any e-commerce website such as Amazon, the AC Delco Connection, eBay, and Advance. In order to create an ACES file, we need to use the following 2 components from the ACES standard. The part database defines the part, and the vehicle database defines the vehicle. Let's explain the example of a PCDB. AC Delco has approximately 120,000 parts assigned to 3,200 part types. Database of automotive part types and positions are grouped into categories and subcategories. Here we have a part type of 8852, which is a windshield wiper blade, which is the standard part type used in the aftermarket. Then we have positions assigned to part types that need them, and you can see the windshield wiper blade has several. Each unique combination of category, subcategory, part type ID, position ID gets us master ID. This is an example of a vehicle configuration database. This is just a couple tables in the database. This shows you a 2015 GMC Sierra 1500, which has a unique base vehicle ID. The submodel is unique also. The 1500 SLT versus the SLE has a different vehicle ID. This shows the values of the engine configuration value, which describes the engine. In addition, there is a body type to identify it's a crew cab, extended cab, or a standard cab, and the drive type too. All of these are just examples of the various tables because there are too many to show. So how do we convert the data from ARAPA to ACES? It starts with mapping. The cataloging team uses their resources to map VIN information and ARAPA information to the Auto Care Association vehicle codes from the VCDB. While the vehicle map uses vehicle codes from the VCDB, part type mapping uses ARAPA part numbers and service name to the Auto Care Association part types for the PCDB. The cataloging team uses a GM ARAPA data and the part type IDs from the Auto Care Association PCDB to create the part type map. On your left, you can see the ARAPA GM data. On your right, you can see the PCDB provided by the Auto Care Association. On the bottom, you can see the part type map that the cataloging team builds and maintains. Notice the number in the upper left-hand side, which has been circled and is equivalent to what is shown on the bottom. The following is a demonstration of how information actually correlates and is put into the part type map. Creating the vehicle map involves mapping process that starts with the VIN number. Key components of the VIN data that provide details of the vehicle are parsed for use in the map. Using the VIN card helps us decipher what the VIN digits represent. Certain digits in the VIN tell us what this vehicle is. Basically, digits 1 through 10, with the exception of 9, we use in the map. This particular example shows us using the VIN card we can decode this vehicle being built in Mexico and it's a General Motors truck. The digit tells us it's a body style 43 vehicle, so it's a crew cab. These two digits tell us it's a 4x4, 1500 GMC Sierra, and the trim level is a SLT. The 8th digit, along with the RPO string, shows us the actual engine. Therefore, the L83 represents the engine in this vehicle. The 10th digit represents the year. At the top, you'll notice the same VIN data from before. Below is the actual map. First, we use the 1 through 8 digits as part of the map. Then we use the 10th. Next, we add in the market code because that is a key, especially for trucks. This is a piece of important information. It tells the wheelbase most of the time for the truck, and then of course the engine and the transmission. All of the green codes in the map are coming from the VIN data. The green codes tell us we know what the vehicle is and what engine and transmission it was built with. Next, we add in the map the appropriate codes in red from the VCDB. The VCDB, which equates to the vehicle and the engine that was shown earlier. Therefore, as stated before, the base vehicle ID of 129846 represents the 2015 GMC Sierra 1500. We know it was a drive type ID of 8, which tells us that it was a 4-wheel drive. Finally, all the red codes are what we are applying based on what we know from the vehicle. The information in blue represents the ARAPA codes. This map is used for two main purposes. The information in purple is sent to anyone who needs VIN decoding. For example, the illustrated catalog, that information can decode a VIN to what vehicle it is. The information in gold is how we do the conversion from the ARAPA to ACES. Once we have all the data mapped, we now need to execute the final process, which is to convert the data to ACES. This is a summary of the final process flow, which is known as the gizmo process. The detailed level of how the gizmo process works will be in the following slides. Here again, you'll notice we have a record from ARAPA. This is the same record from ARAPA that we have been looking at. The top represents a record from ARAPA, while the bottom represents a record in a flat file which has been exported out of ARAPA. Each field on the top has correlating information on the bottom. This data is pulled out once a month and put into a flat file, which we get as part of the ARAPA draw. Millions of records come out every month that get converted. Every ARAPA record potentially could represent more than one vehicle. Before the conversion can start, we have to expand this data and find each unique vehicle that are within here. For this record, it represents 12 different records. 3 years, 2015 through 2017, 2 different divisions, which are Chevrolet and GMC, 2 different drive types, which are rear-wheel drive and 4-wheel drive, 1 series wheelbase, which is equal to 155, 1 body style, which is equal to a crew cab, represented by the number 43. This is a representation of your 12 records. This is a representation of 12 individual records expanded from the previous slide. As you can see, it creates separate records for the year, division, model, and series body style combination. Here we have 12 individual records expanded. We have taken those records and compared them to the map. The vehicle map is at the bottom. To the right is the ACES XML output record, which we are building. The codes which are in blue are compared to the map, which then allows us to identify the base vehicle ID, the body type, and the number of doors that we need for the ACES record. This is where some of the rules and logic come into play. For example, the record we are looking at, if it has the 4-wheel drive and the 2-wheel drive, then we do not need the drive types. This is a kind of logic that goes into the gizmo itself. Let's compare the part map to get the part type code. At the top, you'll notice an expanded ARAPA record. At the bottom, you'll notice a part type map. To the right, you will see the ACES XML output. We have already completed the vehicle map. Now let's look at the part type code. Because the ACES record has to tell you the vehicle and the part, the 12 records are now compared by the part number, UPC, FNA, and the hand indicator to identify from the map that it is a fuel pump modular assembly, which is put in the ACES record. Now we've completed ACES record for this part number and this one particular record. So let's reiterate the final result of vehicle and part mapping. This should look familiar to you. This illustrates our final goal. We have successfully converted our ACES record to a shareable format which can be used to provide data for our online catalog.